In today's video lecture, we will understand the working principles behind a gas turbine engine. Gas turbines are used mainly for two purposes. First, for power production. Second, for generating thrust force in an aircraft. Even though functions are different, working principle behind each case is the same. Let us understand how gas turbine engine is used for generating thrust force in an aircraft. Here is a close look at gas turbine engine of an aircraft. In order to make the flight move forward, this engine should produce a force in forward direction. This force is produced by jet effect of this exit fluid. When a high-velocity fluid is ejected the engine, it will produce a reaction force which will power the aircraft. This force is known as jet force. By applying Newton's second law of motion to jet engine controlled volume, one can easily find out magnitude of this jet force. It is momentum at minus momentum in. So if jet velocity is high, it means high jet force. This is why exit portion of a jet engine has got decreasing area if the flow is subsonic. Or, the exit portion acts like nozzle, which increases jet velocity. The million-dollar question. How to produce such a high-velocity jet continuously? We will produce it by a combustion process, by injecting fuel into it, which will produce flames with very high velocity. But for a sustainable combustion process, we need the inlet air to the combustion chamber to be at high temperature and pressure. This is achieved with help of diffuser plus compressor arrangement. Air gets into the engine by forward motion of engine and sucking effect of compressor. Diffuser increases pressure of this fluid to some extent by converting some part of kinetic energy to pressure energy. After that compressor comes, where both pressure and temperature of the air is raised by energy addition from compressor. So at outlet of the compressor, we will have air at high pressure and high temperature. But compressor requires some power input to do that. This power is given by a turbine which is situated right after the combustion chamber. The turbine absorbs some amount of energy from the high-energy fluid and transmits it to the compressor. Thus, the process of producing high-velocity jet at outlet has become self-sustainable. We will get continuous supply of high-velocity jet and thrust force to this aircraft, thanks to synchronized working of all these components. That is, the diffuser, compressor, combustion chamber, turbine and nozzles. Let's see how energy level of fluid changes from inlet of gas turbine engine to exit. Assume this is the inlet point in a temperature entropy diagram, which is same as state of surrounding air. Due to diffuser effect, pressure and temperature of the fluid increases slightly. Entropy remains same assuming this is an adiabatic, reversible process. Next, in compressor stage also, same process continues, and temperature and pressure rise to a level where combustion process is sustainable. Now, heat addition to the fluid. This process happens almost at constant pressure, and temperature of the stream raises to very high level. Right after that, turbine will absorb some amount of energy, which is required by the compressor. So here temperature and pressure of the fluid come down. The last section, which produces high-velocity jet. Nozzle. This is again a constant entropy process, where internal energy of the fluid gets converted into kinetic energy. Here pressure of stream expands to the surrounding pressure. It should be noted here that the exit stream never goes back to the inlet condition. At inlet it sucks fresh steam of air in. So this is an open cycle process. But, since both these points are having same pressure, we can assume a pseudo-constant pressure process like this, in order to complete the cycle. This cycle is called a Brayton cycle. That is all about working of gas turbine engine. Thank you for watching the video.